Welcome to 24 Hours of PASS, the SQL Server 2014 edition. We're excited you could join us today for Evgeny Tarnovsky and Bill Khan's session on SQL Server 2014 upgrade, a case study featuring in-memory OLTP and hybrid cloud scenarios. This 24 Hours of PASS event consists of 24 consecutive live webcasts. For session schedules and other updates, please refer to 24hoursofpass.com. My name is Julie Cosmano, a consultant at Love Support Solutions. I have a few housekeeping slides before I hand over to Evgeny and Bill, who will speak for 40 to 45 minutes, followed by Q&A time where you can ask them questions you may have. Next slide, please. Please raise your hand using the hand icon on the right-hand side of your screen if you have any issues, and someone will assist you. To maximize your screen, use the Zoom button located on the top of the presentation window. As all attendees are muted, you can ask questions on the question pane, which is located on the right side of your screen. Once we get to the Q&A portion of the session, I'll read off your questions to the speakers. There will be a short evaluation at the end of the session, and your feedback is very important to us, so please take a moment to complete it. It will show up on your screen. Next slide, please. Now I'd like to bring your attention to our sponsor here, Microsoft, who is one of the global sponsors. The staging of 24 Hours of PASS would not be possible without their support and dedication, and they are the reason this event is available free of charge. Next slide, please. As you may already know, taking place in Seattle, Washington from November 4th to 7th, PASS Summit 2014 will feature over 200 sessions with world-class SQL Server experts. Planned and presented by the SQL Server community for the SQL Server community, PASS Summit is single-handedly the largest gathering of SQL Server and BI professionals. With over 5,000 attendees from all over the world, PASS Summit is also a great place to network and meet face-to-face with experts, peers, and MVPs. More importantly, PASS Summit delivers on providing you with the answers to your SQL Server issues, along with the knowledge, strategies, and skills you need to stay ahead of the curve. Contact your local chapter and virtual chapter for a discount code to save $150 off. Optimize your savings by registering before this Friday, June 27th. To find out more about PASS Summit, please visit passsummit.com. Next slide, please. And now please allow me to present the speakers of the hour, Evgeny and Bill. Over to you, Evgeny and Bill.
Thank you so much. So myself and Bill, we work for the Data Platform Group, which is responsible for SQL Server, Windows Azure SQL Server, and a host of other SQL Server portfolio of products. Myself, I'm a program manager, and Bill is a service engineer here within the group. So without further ado, let's get right into the presentation. I want to start off with a bit of a caveat. Originally, this presentation was prepared for TechEd North America 2014. We presented this talk in Houston about a month or so ago. There we had 90 minutes to speak. Here, as Julie mentioned, we have 40 to 45 minutes. So unfortunately, we did have to cut some content. We'll point out exactly where that was. We'll still walk you through all the great features that we wanted to walk you through, but unfortunately some demos aren't available. So we'd encourage you to go back, and if you're interested, watch those demos in the recording. We'll have a link for you at the end of the presentation. So let's get right into it. Okay, so SQL Server 2014 feature overview. Of course, upgrading to the latest and greatest technologies is always, as an engineer, a cool thing to do, to play around with these awesome new features. But even for us working within Microsoft, we absolutely need business justification to do so. For us, there was 3 areas for the system that Bill and myself own that we wanted to start implementing some of these SQL 2014 features. I'll talk you guys through the gaps here, and I'll let you know which features we actually used to address them. The first one was performance. While our data and while our customer load was being met, we in fact did some studies and determined that a little bit down the line, perhaps a year or so in the future, given current growth rates, we'll actually not be able to do so. And so we had 2 options here. do we either buy bigger and better hardware to support that, and that's a perfectly valid option, or do we try and do something with potentially existing hardware, see if we can get some performance gains for free, so to say. And so we decided to go with the second option and implemented a feature called In-Memory OLTP. Now, hopefully you guys have all heard of In-Memory OLTP by now. It's probably the premier feature in SQL Server 2014. There's already been a bunch of great sessions here at the 24 hours have passed around this technology, and there's a few more here coming up after us. Essentially what In-Memory OLTP allows you to do is to take your tables and other database entities and move them into your RAM. RAM, of course, is becoming cheaper and cheaper in greater and greater quantities. And even compared to an SSD, it's a lot faster than the traditional disk-based storage. And so if you actually move all of that to your RAM, you get really, really good performance gains. In addition, you also have the ability to do what are called natively compiled storages, which specifically address and interact with the in-memory tables. The next feature we have is around backup. As you guys can see from the picture, I'm sure you guys might have something familiar, or something similar, I should say. The way that we did our backup was essentially we would take a local backup onto the server for short-term backup. And for long-term backup, we would have tape drives that would then be stored in an off-site location in case of, we need to restore somewhere else. So the reason why we wanted to address our backup situation was because backup was a very costly and a very time-consuming process for us. Someone, of course, has to go in, manage all these physical tapes, move them over to the off-site location. You have to pay for the off-site location. You have to pay for the hardware. You have to pay for the human resources to do so for what amounts to essentially manual labor. And I think we don't much rather be doing a lot of cool new DBA type work rather than walking around and messing around with tapes. And so for the sake of cost saving and for the sake of efficiency, we implemented a feature called Managed Backup. And what Managed Backup allows you to do is to set the entities in your database that you want to back up and to set your retention policy. At this point, SQL Server knows when it needs to back things up, what it needs to back up, etc. And so backup becomes a very hands-off procedure. To top it all off, the backups happen into Windows Azure Storage. And so you no longer need to worry about the hardware and the lab space and all that other costly infrastructure that you would normally have to have with a backup solution. Finally, on disaster readiness. Certainly backup is a great option to prepare yourself for things like power outage, like hardware failure, or like, heaven forbid, natural disasters. However, with backups, as you can imagine, with the tape being stored offsite, it's a very time-consuming process to restore your service. In today's world, our customers expect us to be up 24/7, 365 days a year, and so we really can't allow ourselves to take the days or perhaps even weeks that doing a backup restore would take. And so for disaster readiness, we implemented another feature called SQL Data Files in Windows Azure Storage. The name is a bit of a mouthful, but it describes exactly what the feature does. It allows you to have your SQL Server, your physical SQL Server, on-premise with your data files being stored in Windows Azure Storage. What this means practically is that if you have another box somewhere in an off-site location with SQL Server installed and ready to go, all you have to do in case of a disaster is join that SQL Server to the data files living out in Windows Azure Storage and be back up and running. In fact, you can actually use Windows Azure VMs with this feature and just have a VM sitting idle in Azure in case something like this happens. So those are the three main features we'll be talking about today. A little bit about the databases that we'll be discussing as well. To briefly give you an idea of what the service is, we run the automated test execution system here at SQL. What this means is that all the automated tests that we need to execute to ship the quality product that you guys expect from us, we support all the background services and infrastructure that take care of that. These are mission critical, needless to say. If we didn't have the automated tests in place, There's so many of them that we simply wouldn't be able to do manual testing and ship you guys the products that you expect. And especially now with Azure, where some of our services are shipping as often as daily, we simply cannot allow any downtime. The typical load profile of these databases is automation, like I mentioned. There's some limited manual reporting queries, and what these typically look at is digging into any test failures, or perhaps looking at trends for a particular component to see the quality, things like that. The last thing I want to mention around, in general, all of these databases is that they were designed quite a long time ago, in fact, over a decade ago for some of them. The reason I bring this up is because some of you might not be on the latest version of SQL, or indeed a late version of SQL. Some of you might be on 2005, 2008, etc. And I want to reiterate that, yes, it will take you a little bit more effort in preparation, and yes, it will take a little bit more work, but it's absolutely not outside the realm of possibilities for you to go and start implementing some of these cool new features, even if your design and architecture are a little older. The databases themselves all have to meet the 99.9% availability SLA, and as far as the workload is concerned, range from anywhere around 100 transactions per second all the way up to peaks of 25,000 transactions per second. Storage-wise, they fall between about 10 gigabytes and a terabyte and a half. Hopefully, somewhere within this range, your databases are, and so you can relate what we'll be talking about today to what you guys have in your own labs and services. So we'll start with our first database and our first feature. This is the lab database. So the problem here was twofold. First of all, we had non-uniform hardware, right? So we started with one server, pretty typical architecture for when this database was designed. Always-on availability groups became available to us, and so we added another machine to the mix. Then we decided we needed, for performance sake, to add a read-only secondary machine as well. Everything was non-uniform in hardware specification, and in fact that original machine was approaching its end of life and end of warranty, and so needed to be replaced. We also wanted to upgrade to Windows Server 2012 R2 to allow for standardization across the rest of our infrastructure, as well as to make use of some of the awesome new features that are available in that release, and to be on the most stable, most reliable, and latest version of Windows Server as well. The performance bottlenecks, as I alluded to, were going to become an issue here, and so we wanted to set ourselves up to be able to use some technologies like In-Memory OLTP down the line, and so the upgrade to SQL Server 2014 became necessary. Finally, there was close to zero tolerance for downtime. The 99% SLA had to be met. There's constant workload against this database, and so we couldn't afford any downtime whatsoever. So what did we do to address all of these issues? And in fact, to upgrade to SQL Server 2014 so that we can start making use of some of the really cool new features available within there? Well, we performed a procedure called a cross-cluster migration, which allows you to go from different versions of OS and different versions of SQL and end up with the latest version. The result of all this was, after performing the migration, we only ended up incurring 3 minutes of downtime. I'll remind you guys that this is a database roughly 1 terabyte in size with close to 20,000 transactions per second peaks. And so our customers, actually, we did not get a single complaint. Anyone barely even noticed, and in fact the retry policies on all our clients took care of pretty much addressing all of that downtime. So very happy with that. For this one, Bill will walk you guys through the procedure. Unfortunately, this is one of the ones we didn't have time to show you guys a demo today. But again, if you go to the recording of our TechEd session, you guys will see that. So without further ado, Bill?
So the cross-cluster OS migration for the availability group. If you look at the slide here, we have an availability group here. We have a 3-node cluster. Our goal is really to move that infrastructure to Windows Server 2012 and then SQL Server 2014. So our challenge is that the Windows cluster, we cannot just go upgrade to Windows 2012. We have to do some sort of a backup and restores, build a new hardware there, and then install our SQL Server. And so it's very time consuming. Our goal is also to minimize that downtime and to meet that SLA. So what we do is we provision out our new hardwares, and then we upgrade all of our secondary in the availability group to the 2014s. Then we will fill over to the one of the nodes that we have not been upgraded, which is our primary node. We fill over to that, and we did the upgrade there. The next slide, the next one is we'll upgrade the old primary to the SQL Server 2014. At this stage, all of our nodes, all of our cluster, all of our replicas that is on Windows Server 2008 has been upgraded to 2014. What we do after that is we have the new boxes created on Windows Server 2012 cluster, 3 nodes, and then what we do is we switch the nodes, the 4 and the 5 and the 6, to use that remote clusters, which is the 2008 cluster. It's a simple T-SQL procedure to switch that. Then we'll start adding the nodes, because at that time I can just go to my availability group and start adding those 3 replicas there. And then this is what I call the data synchronization stage. And once they're synchronized, you're ready to do the to proceed with the start of the downtime. So I want you guys to know that this procedure is based on this white paper on MSDN for performing the cluster OS migration for the availability group. In that white paper has the PowerShell scripts, which the PowerShell scripts simply just execute the T-SQL procedures, T-SQL statements. So in that procedure, in that script, we'll delete the AG listener, the availability group listener. And that's the start of the downtime. Then we set the DB offline, the AG offline. And the next one, we proceed to switch that nodes 4, 5, and 6, which is on the 20 and 12 cluster, back to use the local one. Then we'll create a new availability group and the AG listener. And in the end, it only took us about 3 minutes of downtime to kind of migrate everything's over. So there's something that you can definitely do beforehand, before the deployment day, such as that data synchronization stage. And then when the deployment day starts, you simply just execute that script. It will just delete the listener, set the AG offline, switch the nodes, create a new group, and then new listeners, and then be up and running by that time. So the learnings and recommendations. So read the documentations in that white paper. The documentation I refer to is just go to the MSDN, the SQL Server books online, SQL 2014 books online. There's an upgrade checklist. Basically check for your deprecated feature. If your application is a legacy app, it might be using the deprecated features. Check your compatibility level settings. Do you want to use the new compatibility level that is in SQL Server 2014 to take advantage of the new cardinality estimate? And also you want to check your query plans, whether or not your query plan changes over the upgrades. Create a deployment walkthrough for your scenario. Have a test environment or staging environment that can mimic your production deployment. And use a script wherever possible. The white paper has a PowerShell scripts, and in there it talks about the configurations of that script. You can either migrate multiple availability group together, and multiple AG listener together, or just single availability group. Assess your infrastructures and features being used. For example, we have the transactional replications. So in that situations, you want to upgrade the distributors first, then upgrade your publisher and your subscribers. Otherwise, if you upgrade your publisher first, and then you're going to have problems when you're trying to add your secondary publisher to the distributor. You'll run into some errors. So assess your infrastructure, understand how the clusters are used, how do we set up new clusters. If you do strictly the DBA work, then you might want to talk to your sysadmins or cluster admins and say, hey, you know what, I need to grant certain permission to the computer objects, cluster objects, things like that. So make sure you understand all of that and then partner with those folks to make sure this deployment works as it intends to. Migration, stick to your plan, have a rollback plan ready. at various points. Just kind of test and retest that migration scenario. In our case, I think we went through dozens and dozens of tests and retests. This allowed us to meet that SLA, that only 3 minutes of downtime.
All right, thank you, Bill. We're going to talk about our next database. For this one, we'll be talking about two things. We'll be talking about In-Memory OLTP, and we'll be talking about managed backup. So the problem for this particular database, we had a high incoming data load for this particular database. What its purpose was to collect data around about 8,100 client machines, around availability, exceptions, stack traces, service telemetry, that type of thing. Now, this is one of the few databases where we were actually running into active issues as far as handling all that load. As you can imagine, things like stack traces are very large data, and so 8,100 clients constantly pushing that data really eats up performance. And so we had a bottleneck at about 3,800 transactions per second. At that point, once we hit that load, we would start getting backups due to latching, which resulted in data gaps. Needless to say, data gaps are not a good thing when you're trying to determine your service uptime and your service information. Also, backup, as I mentioned, all those issues around requiring costly management, costly facilities and hardware, we wanted to do away with all that. And we actually implemented the backup feature on all the databases we talked about, but we thought it's cool to show you the fact that In-Memory OLTP can actually also work with this perfectly fine. So what did we do? We implemented In-Memory OLTP to address the performance gaps, and we implemented Managed Backup to handle our backup scenario. The results were really, really cool for us. As far as the performance, we got 6 times gains on our input rate. So the database was able to handle up to 23,500 transactions per second. Now, this is a very, very conservative number. And the reason I say this is because 23,500 transactions per second is simply all the load that we were getting. If the database and if the load grows, we could possibly have even more load being handled. But we simply ran out of load. And so the 6 times might actually be even more. Some of our other customers have reported as much as 30 times gains when moving to In-Memory OLTP. Also, on the read side, right, the daily report execution time got reduced by 30 to 80%, which for our customers was a great thing because instead of now having just a nightly report that takes forever to execute and forever to process, they could now actually perhaps run it ad hoc or have it sent 4 or 5 times a day, whatever their business requirements were. Finally, as far as the backup system is concerned, since we implemented Managed Backup, backup became an almost hands-off procedure. The only thing that we did with Managed Backup was every now and then, perhaps every 2 weeks, every month, even every quarter, just check, make sure everything is in working condition. And beyond that, it's an absolutely hands-off procedure. So we saved a ton of cost, a ton of work for ourselves by implementing that feature. So Bill is going to talk you guys through the architecture that we implemented with In-Memory OLTP, and then he'll give you a demo of how to actually implement Managed Backup. So Bill?
So hardware architecture for this is MDB. So we have a hardware, and before we start using these In-Memory OLTP, our existing hardware was on the very 120 gigs of RAMs, and then we have a very traditional. We have a local storage there. We also have a couple of LUNs that's attached to the SAN. This on Server 2008 and SQL 2012. We also have the availability group, which we do the local backup, and then we ship that backup offsite. After we implemented the In-Memory OLTP, we did the upgrades on the memory. We pumped up the memory to 512 gig. We also procured a couple of the SSD to host our 10 DBs in the log file to improve the IOs there. And then we also have the server running on the Server 2012 and the SQL Server 2014 to take advantage of course, the In-Memory OLTP. We still have the the availability group there, and then we have implemented the managed backup. We definitely reduce our administrative overhead on managing those backups, and then ship it offsite. So service architecture for our in-memory OLTP solutions. So we have a web service that 24/7 collects the performance counters from the client's machines, the exceptions from the applications, and the stack traces from the applications. We have the T-SQL store procedure that does the insert into the disk space table, and then we have a reporting services, a Power Pivot, and then to interrogate those tables and then make a good reports out of it. And what we use to implement this scenario, this in-memory OLTP scenario, is what we call the shock absorber. And essentially, what the shock absorber refers to is we have a table that turn into an in-memory optimized table. That basically is the shock, because one of the bottlenecks that we have with this application is really just a high insert data rate. That the insert is just so high that it's, we have a hot spot in our table that we just cannot scale that transaction any higher. Since we implemented the in-memory OLTP, this basically eliminated all the latching problems that we have observed. Essentially, we have a same T-SQL store procedure, but in there we're calling the natively compiled store procedure that is in-memory, and then that in-memory store procedure will insert that table into the in-memory tables. So that table is a shock, and it's a hot data. It's a real time. It's 0 to 5 minutes. Then we have another procedure, another ETL that basically move that hot data to a cold data, basically to a disk space tables. And that table provides, up to 30 days of data, approximately 1.5 billion records. And then we still have that reporting services, reports, and then Power Pivot to read the data off those tables.
I think one really cool thing to mention here is one of the most powerful things about the in-memory OLTP that none of our competitors today support, and that's the ability to interrupt between regular standard disk-based tables and stored procedures, as well as our in-memory features. There's a few features that aren't compatible, but for the most part, you really don't have to do too much additional work to actually move things to in-memory, and in fact to use all of the cool new stuff available there.
Yes. So I'm going to do a demo on the managed backup, and we do have a demo on the in-memory OLTP. If you look at our Ticket North America sessions, there's a demo for the in-memory OLTP. But due to time constraint, we're going to move on to the managed backup demo. So over here, just kind of give you some backgrounds on the what I have here. So we have a SQL Servers 2014, and then which we're going to try to implement the managed backup. So first thing first is that managed backups does support the encryption, backup encryption. So strongly suggest you encrypt your backup there, encrypt your backup so it is more secure. So what I'm going to do is, first thing is I'm going to create a credential. So what you need is your identity. This refers to the Azure Storage account. So you do have to go to the Azure Management Portal, go to the storage, and create the storage. And then there you can have the account name, which is your identity. Your secret is basically your access key. So if I will go to here, you see that manage access key. So that will be your managed access key. You can just copy and paste that. So I'm going to do this. Since I have the availability group here, you want to make sure that you have your certificate on all of your replicas. This is why I have the same certificate on the replica. So I'm just going to do this. I'm just going to execute this. And what is also interesting is you don't need to do a lot to enable this management backup. You can either go through the store procedure here, which is essentially just turn on that switch, enable that backup. So managed backup gives you two different types of control. One is an instance level, another is a database level. Instance level is the whole SQL Server instance. Whenever you create a new database or whatnot, it automatically just manage it for you, backup for you. You can also override that with your database level. But in this case, I'm going to use the instance level. So I'm going to do this. I'm just going to run the whole thing. So what this allows me to do is actually enable that backup. And then if you choose to use the GUI version, the UI version, just go to your SQL Server instance under the management node. You'll see the managed backup. And then what you do is you just go to properties. You can enable that backup. Choose your potential, your storage URL, your encryption methods. So you can do that from the UI or the T-SQL script. So it doesn't take a whole lot to actually enable this feature in your current SQL Server 2014 environment. And once that is there, what you do is I'm going to check the backup location. And in here you can see that, like what I've done previously, is I actually triggered the backup. I run some workload against my database, and then the managed backups sense that we need to do a full database backup, and there you go. So in this case, I'm actually going to trigger the backup here. I'm just going to create a database, and then I'm going to run the whole thing. What this does is kind of run the kind of a generic application workload to insert data in there. And then I'm going to check the backup location to make sure that is backed up. So I want to talk about the some of the features of the managed backup. It only does the full database backup and the log backups currently supported. The full database backup kicked off automatically if the managed backup is enabled, the database or the instance level. If the T-log has grown more than 1 gigabyte in size, if the log chain is broken. So if somebody runs a backup log with the truncate options, then definitely your log chain is broken, and this managed backup knows that, and it will do the full database backup for you. T-SQL backup is a backup file is deleted, or the backup files are overwritten with a different backup or something else. Same thing for T-log. The transaction log backup is kicked off automatically if a database has about more than 5 megabytes of T-log change. So in this case, I'm running this insert in a loop. This will definitely trigger some transaction log backup there, or even more than 2 hours since the last log backup was taken.
So one thing that's important to note here is that this is an intelligent way of actually doing it. It's completely hands-off. If you still want to take advantage of having your backups be in the cloud, but not actually have SQL Server do all the policy for you, you might have some business logic, business rules that dictate that backups have to be taken in a certain way and a certain frequency. There's another feature called backup to URL, which allows you to simply specify the Windows Azure Storage URL and actually specify the policy yourself. So that's yet another really cool way to implement disaster recovery and backup.
Okay. So keep in mind that the system databases cannot be backed up using this managed backup feature. That both the T-SQL and SSMS, like I talked about, support it. So what I'm going to do is I'll show you a screenshot of it. That once this is, so what you're going to see is that it automatically creates a container for you. Once you enable that backup, this managed backup, enable that, it creates that container for you. And you can see that my full database backup is in there. This is because I triggered that workload. So this is not a whole lot to, pretty much just the hands-off for the DBA. By simply just enabling your databases to use the managed backup, or your instance, SQL Server instance to use the managed backup. So So learning this recommendation. So for the in-memory OLTP, just kind of understand your workloads and bottlenecks. We determined that our bottlenecks is really just a high insert data rate, which means that we just have a lot of client connecting to it and just insert a lot of stuff, and we just that creates a hot regions in the table that it just can't scale fast enough. So once basically a latching issue. So once we identified the bottleneck, then we figured out, hey, should we need to partition an application to make sure that this or implement in-memory OLTP to make this to scale that transaction even more. So what can you do to kind of see if the in-memory OLTP can take advantage of? One thing is that you have in the management data warehouse, you can enable these two reports. It's called Memory Optimization Advisor and the Native Compilation Advisor tools. What this really does is give you a kind of a cost and benefits, how much of effort you want to put into modify your application versus the benefits, how much you can get out of it. In this case, for us, it's like, wow, we see a little bit of application modifications, but give us the biggest benefits. So without really spending a lot of cycles on recodings and then re-architect our application, we can quickly take advantage of that situation. Understand your apps. Look at your architectural patterns and implementations. Not all the scenario can take advantage of the in-memory OLTP, so just make sure you understand your application. Perform targeted migrations and repeat that process. Basically, what I'm trying to say is that you have to have some sort of a staging environment where you can test and retest this type of performance.
All right, before we move on to the next one, I just wanted to add that for in-memory OLTP, we showed you guys the so-called shock absorber design. There's a few more. There's a white paper that we link to at the end to talk you through some other architectural patterns. Once you guys execute that migration advisor, it will tell you exactly which tables and which stored procedures are the most beneficial to migrate. It will actually give you a chart of the effort that will be required to migrate based on perhaps features that aren't supported by in-memory OLTP and the benefit you'll get. So you can actually start with just a single table, perhaps your worst hitter, the one that has the most to gain from migrating to in-memory OLTP, and then keep going and keep addressing further bottlenecks as they come up. So let's get to our last database here. This is a fairly simple one. This was around disaster recovery. So for us, I kind of walked you guys through why we need disaster recovery. I don't think I need to tell anyone on what disaster recovery is, but we want the MTTR, the mean time to recovery, to be as small as possible. And so we implemented SQL data files in Windows Azure Storage for this particular database as a hybrid solution for us. This is a table, or this is rather a database where we still wanted some control over the physical location of the server, and so we couldn't actually go full Azure here, or at least initially without some re-architecture, and so we ended up using this solution. Bill will walk you guys through how to do this too.
So the architectural for the SQL Common Lab DBs is we have the availability group on SQL Server 2014. We have a readable secondary file, which is readable secondary replica, which all of our reports are pointing to. We simply wanted to move that log in the data file to use the Windows Azure Storage, put the data files over there. So in the next demo, what I'm going to do is I'm going to show you guys kind of how you do that. So back on restore. So what I'm going to do is move the data log file from the on-prem SQL Server to the Azure block storage. So of course you're going to have. I wanted to make sure I want to encrypt my data. So I create a certificate. I need to back up that certificate. And then you do need to set up a credential. So this credential is basically from your container. So copy paste that from your container. You can just go to the Azure Management Portal and copy and paste that. identity has to be the SAS signature, shared access signature. You can get that from the Windows Azure Storage tool, which I'm not going to go through this due to the time constraint. But essentially, go to the security. You can create your policy, and then you can start generating the signature. This is how I got that signature, is right there. So I copy-pasted that. So I'm going to set up the credential. Then I'm going to verify that my credential is actually there. Then I'm going to connect to the Azure Storage. Inside the SSMS Studio, you do a connect. This is Azure Storage. What you need is to specify your storage account and the account key, which is the access key. And over here, you can see that I connected to it. I have 2 containers in there. So what I'm going to do now is I'm going to create a database with an encryption on, and it's kind of pulling the data in the log file locally to the machine. So we'll create a database. As you can see that my database is right now is hosted locally, in the local drive. I'm going to set up an encryption there. And I'm also going to back up the database. The backup database also supports an encryption. And then I'm simply just going to restore that database and move that data in the log file to the Azure Blob Storage. The point is I want to show you guys how simple it is to kind of move your data file to the Azure Storage. And I'm going to refresh that, and you can see that I have my database TestDB3. All the log files and the data files are moved to the Azure Storage. So here comes scenarios where we're going to take the database offline, or something happened to your data centers and then your machines wiped out. I'm simply just going to set the database offline. But you do have to, so we have a disaster recovery readiness, and then that you can just go to a virtual machine in the Microsoft Azure space and provision yourself VMs there. But you're going to ask somebody else to do it. But in the case of disasters, you more than likely want to do something else. So you have somebody else to do restore the database for you. So what I'm going to do is ask my coworkers, just kind of go, hey, the data files and log files in the Azure Storage, why don't you just kind of restore that database there, attach them to get us back up and running. So I'm going to do this, create a credential, verify my credentials there, and then I'm going to create a database. So at this time, what's going to happen is that because I already encrypted my database, so even if I try to attach it, I'll run into this error that I just don't have the decryptor to decrypt that certificate. So what I'm going to do is I need to restore that certificate. And then I'm going to see if the database, then I'm going to go back and then attach my data files and log file to the new database I wanted to create. I want to see if my TestDB3 is encrypted, which indeed is. So at this time, without any kind of efforts, if I go to my new instance, I can see that my database TestDB3 is there. So this kind of show you that you can attach the database that's currently in the Azure Storage. You can do a backup and restore, and in the restore statement, you can say I want to move that database, move that data files and log file to the Azure Storage. So it shows you that simplicity into how you implement it. Once you understand the ins and outs of setup and encryptions and then things like that. Also, I wanted to remind you guys that that always back up your credentials, back up your certificate, and secure those keys and access keys and signatures and key files, things like that, in offsite or very secure locations. That's it. So learning is a recommendation from the Common DB using the SQL Azure data files in the Azure Storage. So a lot of steps can be completed prior to that deployment day. Understand that how do you create the storage account, how do you generate that SAS signatures, and then create one container per database for the isolation. For example, like you can have one container for your database 1 or your instance 1, and then from there you can have a different database underneath it. So that for administrations and management of overhead there. So think about the security, like I just mentioned. Moving to the cloud generates a lot of keys into certificates and other collaterals. Those need to be securely stored. Determine the security protocols such as rotating keys and passwords. Harness the cloud. So this scenario that we're trying to do is relative for the HADR scenario. That we wanted to make sure that in the case of disaster, we can quickly recover from it without so much of the efforts. So harness that cloud is the right choice, right approach for us.
All right, thank you, Bill. So we're going to wrap up, and then we're going to take some questions from you, but we did want to conclude with a few overall themes here today. First of all, SQL Server 2014 as a release introduces a huge amount of new opportunities with the new features that are presented. We talked specifically about performance, disaster recovery, and simplified backup scenarios, but there's a lot more to the release than just these. Read about the release, learn about all of the new features, see how you can implement them. There's a lot of benefits to be gained from upgrading. There's a lot of return on investment, and get familiar with it. As far as planning, this was an overall theme that we also presented. Make sure you do a lot of planning. None of the procedures we showed you guys today are particularly difficult, but you still want to understand the end-to-end procedure. You want to have practiced it. You want to just know the ins and outs of those features. And that will make deployment go extremely smooth for you. There's no reason it won't. The procedures themselves are fairly simple. Finally, as far as migration is concerned, now that you did your planning and you actually have your entire deployment process determined, automate as much of it as possible. Determine where you need to have rollback points, right? Where are your points of no return? How do you get back from those? And use the staged approach. Don't deploy everything at once. Deploy one feature, let it bake for a bit, deploy the next one, and that way you can watch how things are operating, make sure that if something does unfortunately go wrong, that you know exactly where the problem lies. So just some overall themes here for you guys. Some useful links that I wanted to share with you. Julie was kind enough to already provide you guys a link to our presentation from TechEnd, but there it is again. Cross-cluster migration white paper and scripts. Bill alluded to that a few times during his presentation on the procedure. We have a link for that. Finally, we have a link to the white paper around different workload patterns and migration considerations. There's also a TechEd session around that where we have some real customers from the field presenting their experiences with In-Memory OLTP, and that's a session that seems to resonate very well with our customers, so we'd recommend you guys watch that as well. We also have MSDN entries for books online for all the cool new features we talked about today. So with that said, we have about 10 minutes to take your guys' questions. We talked about a lot of different features, so let us know what's on your minds.
Okay, great timing. Thank you very much for that. And I'm just wondering with the links, because the audience won't be able to click on the slide, is it possible to have it posted somewhere that they can visit?
So I believe that the slides will actually be posted on the SQL Pass website.
Okay, all right. I'll double check with them. That's fine. So let's just go through the Q&A portion then. All right, so we've got the first question here. If we need to migrate a few tables to in-memory OLTP, what are the precautions they should take before they migrate, and what are the tools available to do this?
So the best thing you can do is run that native memory advisor. There's a few different things you can do there. You can run it for tables, you can run it for store procedures, and it'll actually let you know exactly where your biggest gaps are. Now, if you already know what the gaps are, it will actually generate the migration scripts for you. You need to be aware of some of the limitations of in-memory OLTP. It doesn't have quite 100% backwards compatibility with the traditional T-SQL you used to, but it's getting very close. And so go through MSDN, make sure you're not using any features that actually aren't supported by in-memory OLTP, and also be aware that once you do migrate some things to in-memory OLTP, you can't update them on the fly. There's a few parameters you have to specify when you convert your table from disk-based to in-memory OLTP, and those bucket-sized containers, bucket-sized parameters, and a few other things are kind of static. You'd actually have to drop and recreate your table if you wanted to change those. So be aware of limitations like that. MSDN does a great job, in my opinion, of walking through them, but the biggest ones, like I said, would be go through features that aren't quite supported by in-mem OLTP yet, and go through things which would be difficult to change once finally migrated. Bill, anything else?
Yeah, my recommendation is run that advisor. Simply turn that data collections on and run your application workload, and just run the reports, see what it gives you. The costs and the benefits, and then it's one of the things I really like about that report is just it helps that migration so much easier, because we can understand that how much effort or how much cycle do we have to put into to migrate our database to the in-memory OLTP. So without a lot of guesses.
Okay, cool. So back to the questions around the links. If you go to 24hoursofpass.com, the slides are already uploaded actually. So if you are looking for the links, just go to 24hoursofpass.com and download the slides from there. All right, so next question. Is it possible to integrate managed backups with a third-party tool like NetBackup?
I personally am not familiar with that tool, but managed backup operates against pretty much the exact same general backup procedures that SQL Server uses for local backup as well. Yep. And so I would suspect that it works. I can't promise it. It's something that we'd recommend you set up and you experiment with, and we'd certainly be interested to know if that works for you. One of the really cool things I would recommend is actually go to Windows Azure, spin up a Windows Azure VM with SQL Server 2014. We have all the images up there already. And in fact, all the demos that we showed you today, those were all running on Windows Azure VMs. And so set that up, set up your third-party tool, and just play around with it. See if it does what you need it to do.
Okay. And then last two questions. What about performance? So, for example, internet connection upload or download if you store the data or log files in Azure Storage.
Sure. So you guys will have noticed that we actually only point our read-only secondary to the data files in Windows Azure Storage. Windows Azure Storage does not have a guarantee around IOPS. We do know approximately what the maximum is, but unlike, for instance, VMs where you can specify the exact performance parameters, Windows Azure Storage does not today support that. And so you want to be aware of that, and because obviously your read-only secondary, that'll be in async synchronization mode, that the performance will kind of catch up with itself. As far as the network is concerned, you really want to pick the Azure data center that's closest to you that'll give you the best performance. There's a lot of variation there, and while we can guarantee the network performance within the data itself, we can't really do a whole lot about the network between your site and the data center. And so again, this is something where I would say set it up, play around with it, see what sort of performance you're getting out of it, and whether this is important.
Okay, and I believe this is the last question. If there are examples, also the examples that you've used before, were revised to multi terabytes, so 4 to 7 terabytes databases, would the recommendations change anything? If so, how?
Can you repeat the question? Is it 4 to 7 terabytes?
Yeah. Yeah. That's
I think the Azure Blob Storage only supports up to 1 terabytes. I think that's the limitations there. I think so. Yeah.
So it's actually a little hard to keep up with because the entirety of Windows Azure keeps pushing the limits on a pretty frequent basis. So obviously make sure that the maximum blob size is something that will accommodate your databases. Now, as far as whether there's any difference, of course the initial backup will take a longer period of time just because you're moving so much data across. And there's actually multiple ways to do it, right? You can take a backup locally, upload it in the background, and then just start taking differential backups so that it simply has to catch up with that original backup. That's one way to do it to kind of make your life a little easier, assuming that the blob storage can handle your size.
Yeah, but I believe that the Azure is keep taking on the customers' suggestions. Will keep expanding, but as far as I know, as far as I know, it's 1 terabyte in size. So if you have 4 to 7 terabytes, I'm not sure what's the implications, or I don't know.
Yeah, I'm just trying to take a look here for you to see what the maximum size is, and it looks like, for the sake of time here, I'm not going to look around, but just take a look at MSDN, take a look at the Windows Azure website, and see what the maximum size is.
Okay, excellent. I think that wraps it up. So thank you so much for a really excellent presentation today, Evgeny and Bill. And thank you everyone for attending the session. And just remember there'll be a short survey. Please fill it in, and yeah, and hopefully you'll get to see the rest of the 24 hours of past sessions as well.
Thank you guys. Really appreciate everyone.
Thank you all.